Okay, so really quickly, we're going to be talking about the different kinds of representations for graphs. Okay, so to first start off, we're going to cover these two examples. So if we see these two graphs here, we could clearly see a difference. And that is that this graph here has arrows that are pointing in a specific direction, right? These have arrows pointing in a specific direction, while these ones just have lines pointing, like connecting them, right? There's no arrow. This is just a straight line. So this is what we call a directed graph, right? Okay. So directed graph, and this here is an undirected graph. So a graph where the edges, so these are called edges, where the edges have a direction, we call a directed graph. And when they don't have a direction, then we call this an undirected graph. So these are edges, and then these are vertices of the graph. Okay? So very quickly, we're going to be talking about how to represent these in, for example, for our problems that we're going to be doing in LeetCode, we're going to have to know how to represent them so that we could do different traversals on them. So let's get into that really quickly. So the most common representation that we will see for a typical graph will be using something called an adjacency list. Okay. And what this is going to look like is it's going to look like a hash table where the key is the actual node and the value is all of the nodes it's pointing to. Okay. So let's kind of draw an adjacency list for this graph over here. So if we start off with A is pointing to B. Okay, and this is going to be a list of nodes. So let's just draw it in like a little array. So it's going to be B. And that's it for A. So we're also going to have B as a key in our hash table. And this is now pointing to D and C. Okay. So I guess it doesn't matter what order we put it in, but we're just going to put both nodes in here like that. And the next node is C as a key. And it's pointing to only D. You see here it has an arrow pointing towards D. So we only include the nodes that it is pointing to, right? So we're not including B because this is like, we're not including like this backwards kind of connection. We only care about the nodes that it is pointing towards. And we also have D, which is going to be only E, right? And then we have E, which is just nothing. So we could say it's an empty array or list, okay? So this is very simply an adjacency list, and this is the simplest form of a graph that we can use because it's very easy to traverse. And similarly, I could show you the adjacency list with this undirected graph as opposed to the previous directed graph, just to show you the difference and what it would look like. So in this case, it would be A is pointing to B, right? B, now you see here B has three connections. It has this one, and this one. So three edges. And we're going to include all three of them because these are all bidirectional edges. So we're able to move back and forth between these. So A, C, and D, right? So this is technically pointing towards this, and this is also pointing in this direction. So that's why we included in both directions. So the next key is going to be C, and C has edges towards B and D. And then D has edges towards C and B, or B and C. And then E, oh wait, it also has a connection to D, or E, sorry. It's also connected to this. And then E only simply has a connection to D. Soon we're going to understand why this specific type of structure and representation of this graph is easy to traverse and why it's so useful. But for now, just understanding this format and structure is going to be very useful for us. So going back to the directed graph example, we're going to be covering the next representation, and this is going to be called a adjacency matrix. Okay. So as you may imply, this is going to be in the form typically of like a 2D array. And essentially the rows and the columns are going to be labeled for each of the nodes that are in the graph. Okay. So for all of the rows, it's going to label all of the nodes. And same thing with all the columns. So in this example, it's going to be A to E. Okay. And for a directed graph, essentially, all of the slots in here are either going to be filled in with 0 or 1. And if it's a 0, then that means there is no connection going from one to the other. And if there's a 1, that's going to represent the fact that there is a connection going through from that point to that point, okay? So I'll go through like a few examples. So here we could begin to fill this in. So A to A, this is 0. A to B, so A to B here, this is actually a connection that is happening, right? We see this connection, so this is going to be a 1. A to C, there's no connection. A to D, there's no connection. A to E, there's no connection. So now B to A, there's no connection because we don't care about A pointing to B. We're looking for B pointing to A in this case. So that is going to be 0. B to B is going to be 0. B to C is going to be a 1. As you could see, it's connected to C. And same thing with B to D, it's connected. This is going to be a 0. And we continue doing this. So C is only connected to D. So we'll fill everything in with zeros except for D. And same thing with D. D only points to E. So all of these are going to be zeros except for at E. And then E to A. So all of these are going to be 0 because E does not point to any nodes. Now I can also just go through the example with the undirected graph just very quickly. So we're also going to have all of the rows and columns labeled from A to E for all of the nodes. And we're just going to quickly label all of the connections going on. So A to B is definitely a connection. So for this row, it's only going to be A to B. So 0, 1, 0, 0, 0. And then B to A is going to be 1 because this is a bidirectional edge or connection. This is a 0. So B to C is on, B to D, and this is 0. So now C is going to have B and D at 1. So 1, 0, 1, right? And then 0. And then for D, it's going to be B, C, and E that are all going to be 1. B, C, and E. So A is going to be 0, 1, 1, 0, 1. And then for E, it's only connected to D. So everything else is going to be 0 except for D. And that is the adjacency matrix. So for our last graph representation, we're going to be starting with the undirected graph first because it's a lot easier to represent using this, but it will require us to number our edges. So let me do that really quickly. So let me just number these from 1 through 5, and I'll show you why. So this representation is going to be called a incidence matrix, okay? And essentially what it represents is, so every single row is going to be labeled by the node. So we're going to have A through E for all of the rows. And then for the columns, we're going to have the numbers for the edges. So 1, 2, 3, 4, and 5. So this is what it looks like. It looks like a kind of relationship between the nodes and the edges, as opposed to the last one where it was just nodes to nodes, right? So this is going to be very similar to the adjacency matrix in the sense that the way that we're going to be filling up this little table or this matrix is by doing the same thing where we put a 1 if there is a connection and we put a 0 if there isn't a connection. Okay? So for example, if A is connected to 1 in this case, so A and 1, so A actually has a direct connection from A to B, and it's using this edge, 1. So this we're going to actually label as 1. And same thing with all of these. A doesn't have any, A doesn't touch any of these edges, right? So for these, we're going to be labeling it 0. And we're going to do the same thing with B. But B here actually touches 1, 2, and 3. So these 3 are going to be labeled as 1. So 1, 1, and 1. And then 4 and 5 are going to be zeros. And for C, it only touches 2 and 4. So everything else is going to be a 0. Just like that. And then for D touches 3, 4, and 5. So 1 and 2 are going to be 0. And E only touches 5, so these are all going to be 0. Okay, so now showing this with the directed graph, this is where I was going to say that this is a little bit different, and I could show that really quickly. So we can label the columns and rows. So once again, the rows are going to be the nodes, and the columns are going to be the edge numbers for an incidence matrix. And for this time, using a directed graph, what's going to happen is, so I'll just go along and just label this as I normally would. So A1, so we see here A, and it has a connection with 1, pointing to B, right? So I'll just go and continue labeling this as I normally would, right? So everything else would be 0 because A has no other edges connected to it. But now when we get to B1, we see B is actually getting the edge 1 pointed towards it, right? Like the arrow isn't coming from B to A, it's going from A to B. And the way that we show this in a incidence matrix, because we want to also be able to capture whether or not this is going to it or from it, right? So the way that we do that is we put a -1 here, saying that the edge is pointing to it. So the edge isn't like coming from B, it's being pointed towards B. So that's where we put -1. And we can go ahead and continue labeling this. So B2, so in this case, B2 is actually coming out of B, right? So it's coming from B. So this would be labeled as 1. And the same thing with 3, it's coming from B. This would be 1. And the others will be 0. Now for C, C has no connection to 1. And for C2, 2 is actually being pointed towards C. So this is going to be a -1 as well. And it has no connection to edge 3. And it's going to be 1 for 4 because it's coming from C. And a 0 for 5. Now for D, it has no connection to 1, no connection to 2. But for 3 and 4, both of these arrows are pointing towards D. So this is going to be -1 for both of these. And it's going to be 1 for 5 because it's coming from D towards E. And for E, it's going to be all zeros except for 5, which is going to be -1 because it's being pointed towards it. And also, I just want to clarify something, that this -1, 1, these could be whatever they want to be. Like if there are weights in the graph, and we're going to probably come across different problems where there are weights included in the edges, these would be the weights instead of 1 or -1. But for now, we're putting 1 and -1 just to show the presence of a edge there. So now that we are familiar with the different ways that we can represent a graph, now we can go ahead and have some kind of intuition or approach onto how we're going to solve some slightly more complicated graph problems. If you like this video, make sure to check out my course on Udemy where I go over how to approach and solve LeetCode's top interview questions in Java. This will help you get more comfortable applying concepts like arrays, strings, linked lists, binary trees, dynamic programming, object design, and many other concepts in order to solve problems effectively and ace your interviews. So if you're interested in it, feel free to check it out through the link in the description. And with that being said, I hope you guys have a good rest of your day, and I'll see you in the next video.